Hello guys, so in the previous videos we had a look at the wiring of the John Deere 9560R, and in this video, part 3, we're going to have a look at programming the Arduino. Okay, so now we're ready to download our RC Tractors code. So we need to go to RC Tractors and generic RC Tractor code. Now I call it generic RC Tractor code because it's not intended for a specific tractor. You need to set this code up once you've got it on your Arduino so that it suits your tractor. Once you get to the RC Tractors code page, you can just scroll down and you'll find the code here. So what you want to do is select the code and go Control C. The next thing you want to do is open a new sketch in your Arduino IDE. Then go click on this area and Control V. So now that has copied all of our code into our new sketch. So we need to save this as whatever you want to call this code. So I'm going to be calling this John Deere 9560R. Now that we have our code in the IDE, we can have a look down through it. This first little bit is just saying what it is. It's version 1.0. We have the different pin assignments and how they relate to the tractor, so what each pin in this code is being used for. Then we get down to an important section, which is what describes the tractor. Now, the way that my code works is that the transmitter sends out an ID code, and this ID code relates to only one tractor. In that way you can control all your vehicles from one controller. So in this example, the code I've chosen is F936, and that's obviously the code for the Fendt 936. So the bytes, the ID are saved in bytes and they're in hexadecimal values. So we have 46 is the hexadecimal value for F, 39 is hex for 9, 33 is the hex for 3, 36 is the hex for 6. So I'm working on a John Deere model, so I'm going to call this JD9R. I only have two models. The other one's an 8000 series, this is 9000 series, so I'm going to call this one JD9R. So the first character, J, is 4A in hexadecimal. Then 44 is D in hexadecimal, 39 is 9, and D, or JD9R, so the R is 52. Okay, so that's JD9R. Okay, so that's our ID sorted. So that's going to identify this particular tractor so that we don't accidentally control a different tractor when we want to be controlling this, or this won't be controlled when we're trying to control the Fendt, for example. If you left that alone and put all your tractors with the same code, they'd all try to move at once if you left that code the same. So the next thing we need to do is set up our steering values. Now this is the center value. It's going to be where your steering servo normally sits idle. This will be its minimum, so it's minimum deflection in one direction and its maximum deflection in the other direction. So the reason I have these in here so you can set them is because every tractor is going to be different. So the way I mount my steering servo is going to be different to the way you've mounted your steering servo, and you need to be able to adjust those minimum maximum values to stop damaging, or to prevent you from damaging the servo. So we'll go over and have a look at the tractor now, and I'll show you how to set these values up. Okay, so this code is actually set up for the John Deere already. So what we're going to do is set these values, minimum to 0 and the maximum to FF. That is because in the controller code it's always going to send a value between 0 and 255. Okay, now it's important when you're doing your testing that you remember that B4 is 180 degrees. So don't send the value above B4. But because we've set the limits from 0 to FF, whatever value we do send is exactly the value that we're going to send to the servo. So it's the exact angle. So that way we know exactly our limits. Because if you set the maximum to B4 and you sent 5A, which should be 90 degrees, it wouldn't actually be 5A, it wouldn't be 90 degrees, because your limits would have changed that. It would now be, I'm not sure, probably be 30 something, but so it's important that you set this to 0, 0 and FF for this initial setup. Okay, so now we're ready to program our Arduino. So first thing we need to do is remove the power wire from our FTDI female header here. The reason for that is this USB serial adapter can't provide enough power for the servos that we're after adding to the circuit here. So now we need to use the battery, and we remove this so that we don't interfere with the circuit of the FTDI cable by supplying more current than it's supposed to have. So once you do that, you need to plug in your right angled header like that. Then we need to remove our XB so we don't cause any interference. We can put our header on our Arduino. Apply a little bit of pressure, turn on the power and hit upload, and we should have no problems. Okay, there's an upload happening. And there we go, a successful upload. And that's all there is to it. Okay, now that we have our code uploaded, we need to adjust our steering so that it suits the tractor that we've built. So the first thing we have to remember to put back on our XB, and you hook up a second XB to your USB to serial interface so that you can send serial commands. Then you open a program called XCTU. This program is for setting up XBs, but it also has a useful terminal. So we go to the terminal section, we need to open our COM port, we need to assemble a packet, and that gives us this little option. From here we can type in our command string, so we'll go hex 0A, lets the tractor know a command is coming. We've given it the ID JD9R, and if we go back to hex, there is the hex values for JD9R. We want to do steering, which is 02, and we want a test value. We'll start with 5A, which is 90 degrees in hex. So we switch on our tractor. It's now ready, and we send our command. We've moved slightly, so we'll go for our maximum. So let's try 65. We need to clear away this 5A. We'll try that. Okay, we need to try a little more. We'll try 75 because we haven't gone very far yet. Okay, we've gone quite a bit, but we're not just too tight yet, so let's go a smaller step. We try 80. That's pretty tight over there now, so 80 is our maximum. So let's go the other direction now. We'll try 40. That's pretty far over there as well. So our range, we'll say, is from 40 to 80. Now we have to adjust that in our Arduino code and re-upload. Okay, so now we're going to test or set up our link the same way that we've done our steering. So if you open XCTU on your computer again and have your other XB set up, power this on. So now we're ready to go. Go into your terminal on your XCTU, type in the same command string, well, the first 5 characters are the same, so it should be 0A, 4A, 44, 3952. That's the one for mine. Now, when we done the steering, we typed in command 02 for the steering, but I'm going to use command 0C because that is for the link servo. So I'm going to try 0C 5A for the first attempt, see what we get then. So it looks like 5A hasn't moved the servo, so possibly that is the position that the servo is in. Let's try 80. And 80 has lifted the servo. We could maybe go a little bit further. Let's try 85. That's a bit too far, the servo is kind of struggling there, so let's try 83. So 83 sounds okay. So 83 is our maximum. Let's try 50 for our minimum. We'll try a little bit further. Let's try 45. And try 40. That didn't really move there, I don't think. So 45 is probably good enough for the minimum. So 45 and 83. Well, maybe 82. Okay, so 45 to 82 are going to be the values that I use for my link servo, and I'm going to set the center value to 82 so that when the tractor starts up, the link is up. So that's what I'm going to do now over in the code. Okay, we're back to our code now. We know that we want our link center to be 82. That will make sure that the 3-point link is in the up position when the tractor starts. We want the minimum to be 45 and the maximum to be 82, and that should be the range of our link servo set. Okay, so now we want to test out our drive motor. So we open XCTU again, go to the terminal, create the packet. It's going to be 0A, 4A, 44, 39, 52 for my tractor again, same as before. And now this time the command is 01 for the motor. So the first command I've sent here is a value of 99. That's around about the center value, because our range is from 0 to 255, and 99 in hex is close enough to the center, so the motor's not moving now. So let's go to, we'll send the value to CC, which will be maybe halfway between the middle and full speed. So now we're clearly going in reverse there. So now if I go FF, it should be full speed reverse. There we go, no problem. We go 99 again. That stops the motor. Let's go the other direction. We'll say maybe 44 is kind of in the halfway forward. So there's our speed forward. So if we go 0, 0 now, we should have full speed. So there you go. So our speed control is clearly working, no problem at all. So now it's time to test the LEDs. Okay, so I've added extra green lights to the front of my tractor. They're just under the bonnet, so I need to add extra command for this because it's not a normal addition to a tractor. So we have a pin here, A2, that's not being used, so we're going to use that. Now we need a command that's not being used, so if we scroll down to the bottom of the commands, here is 0D. 0D is not being used, so 0C is the last one that's being used, so we're going to use 0D here. So we need something that switches a digital pin on and off, and the beacon, or no, the spotlights, that is the same code that we're going to need. So let's go up to the spotlights, which is 07. So here's 07. We want what's inside these brackets here, so let's take from here down to here. Now copy that And if we go down to D, we'll find that we have these 3 lines of code already in 0D. So there's 0D, and there's the 3 lines of code. So we want to paste that in here. So now we don't want spots on, so we're going to call this, I'm going to just call this green on, obviously because they're just green lights. So let's say green on, green on. Okay, so that's it. And now the pin that we're using is no longer 13, we are talking about A2. So type A2 in here. So what's going to happen when it gets the first command, if the green lights are off, it's going to turn them on, and if they're not off, so if they're on, so else if they're on, we're going to turn them off. So that's all that happens. That turns A2 low and A2 high, and that switches our lights on and off. So if we go back up, we need to add this new variable green on. So let's go back up to our variables list, and now we see here was spots on, so let's just add it in beside spots on. So we need an integer, we've called it green on, so we'll start off with them being off, so equal to 0, and that's all we need to do. Now we just save this code, compile it, and upload it to our tractor, and we should have control of our lights without any problems. Okay, so to test out our LEDs, we put in our same string again, start with 0A, JD9R, and now this time our command is going to be a specific command for the lights. So we'll start with the left indicator, that's 08, and then we put in 00 for the data value, because our tractor expects to receive 6 bytes with each command string. So 00, it's not going to use that, so it doesn't matter. So let's send that data. We should see our left indicator flashing now. Yeah, so here's our left indicators now. So if we send that same command again, that should turn off our indicators. Okay, so indicators are off. We go to 09, it should be the left indicator. There's 09, and sorry, this is the right indicator, so our right indicator is flashing now. Okay, that's no problem, we'll turn that off again. That's off. Now we'll go for our hazards, which is 0A. So if we send 0A, we should have both indicators flashing. So there you go, all our indicators are now flashing, that's perfect. Send it again, turn it off. Okay, and our beacon is 0B. So send 0B, and here's our beacon flashing here. So you can obviously change the timing of any of these indicators or beacons yourself in the code just by adjusting the delay times. Okay, now we've spun around to the front of the tractor. We'll test out our headlight. So we have our dips, should be 05. So there's our dips on. And if our pulse width modulation works good, we should now have brighter full beams. There you go, slight difference. So that's the full beams. That's off, and this is the dips. There's the dips. And full beams, you see a little bit brighter. Okay, so those LEDs aren't terribly powerful, so the difference is small. But you can adjust that brightness as well in the code. You just need to change the analog right value. So I'll just turn off the headlights. Okay, so I've just uploaded the code for the green light, so let's test that they actually work. So our string again, our command this time is 0D and 00 for data because we're not using the data. So, but we need the 6 bytes, we have to send the 6 bytes or the tractor won't recognize it as proper code. Actually it's 7 bytes, sorry 7 bytes, we need to send 7 bytes. So I'll send the 0D now, so there we go, our green light working. So the new code we just copied over works perfectly fine. So that's how you add your own functions to the tractor. It's pretty simple. If it's the same as something that is already used on the tractor, you just copy the code. Or if you need something special, you might have to write your own code. But that's not too difficult either. And if you need help with that, post to the forum, explain what you want, what you're trying to do, and I'll try and help you solve the problem. So we just tested our headlights, but what about our brake lights? So if we go back again and we type in 05 for our dipped lights, so send that. Now we see our brake lights come on when our headlights are on. Now they're actually not at full brightness, they're probably around about half, because I intend to add braking code later on. So basically there will be a kind of speed control, so the tractor won't just instantly follow the analog joystick. It will speed up and it will slow down gradually, and if you pull the joystick back it will slow down faster and the brake lights will come on. That's what I intend to add to the code later on. Now when I do that, these lights will go from half brightness to full brightness when you pull the joystick back, so when the brakes are on. So that is the plan, and as you can see they're working fine. That's the dipped lights there. Now this should be the full beams, so command 06, and our lights work fine for that too. Okay, so the final thing we need to test is of course our spotlights, which I have on a separate board here on the back of the tractor. So the command for that is 07, so we have our string ending in 0700, because again we're not using the data. So let's send the value. There's our spotlights on. Send it again, it turns it off. So as you can see, that's our tractor tested. I think we've covered pretty much everything except the external servo and the external serial. So we'll just cover the external things now, and that'll be everything. Okay, so I have the external device set up. This is my mower, which basically just has a servo in it, and the servo steers the mower. So the command for the external servo is 03, and I happen to know that the servo in this mower operates between a value of 25 and a value of 50. So it's currently at 25, so let's type 35. And the servo moves a bit. We go 45. Servo will move another bit, and if we go 50, we should lock over completely. Yeah. So there you go. That's our external servo works no problem. The last thing we need to test is our external serial, and my trailer here is controlled by a serial. It takes a 01 to lower the trailer and a 02 to raise the trailer. So in this case the string is 0A, 4A, 44, 39, 52, and the command is 04 to tell it we're working with a external serial, and then the data value is the value that we're going to send via the serial. So the trailer's down, so I want to raise it, so I'm going to send 02 first. So if we send that raises the bed, and we want to put it down now. If it hadn't already fallen down, we would push 01. So I'll do that again, and hopefully the trailer will stay up. There's 02. Okay, it's kind of up. Here's 01. Okay, so that's our external serial is working. Okay, so I think we have tested everything on our tractor, and I've shown you how to set up your tractor on a breadboard so that you can check that everything works. I might have done it a little bit over the top here. I've tested everything all at once because obviously I had to do that to shoot the video, but probably if you were doing this yourself you'd only wire up the motors and servos and that, and you'd probably mount all your LEDs on the tractor already, because you know you're pretty much guaranteed you're going to use them. Although maybe that's not a good idea, because you might burn out an LED by accident before you're ready, before you have your final system. So yeah, it's probably best to do it all on the breadboard first, just to be 100% sure. But that's the tractor tested. So make sure and tune in for the next video. If you're not subscribed, make sure and subscribe so that you get a notification when it's uploaded. and the next video will be wiring this all up and testing the finished model. And that's everything, so thanks very much for watching.